Our next speaker is Vishal, and Vishal will talk about CuttleFish and cloud testing. दिया था कि मुझे कुछ तुमने डॉक्यूमेंट दिया था ना It's fine. Can't you present it? I have no idea how to do that.
Yeah. Hello everyone. Cannot see it. Can I see it? Okay. I'll have to see the slides and talk. Yeah. Can you mirror it here?
Did you want the mirror thing?
Yeah. Possible. Mirror. Yeah. How do I change slides? Yeah. Hello everyone. I'm Vishal. Today I'll be talking about AOSP testing at scale using CuttleFish. We'll go through. This will be the agenda. A quick introduction about me, what I've done in the past, and I guess many will have knowledge how a development workflow works in a company, and Sumit already spoke about Pixel. So this is the agenda we'll go through quickly. I'm Vishal. I have 17 plus years of experience. I've worked as tech lead at Linaro, but now I'm excited to be working as staff DevOPS engineer at source.dev. We're building something very exciting, useful for many Android device makers as well as any manufacturer of Android-based devices. To start with, this is the development workflow in general in any companies where you're working with Android. First, the developers will write patches, and once they've tested it locally, they will submit it to Gerrit, where you have reviewers reviewing the code and posting comments, as Kavi said in the previous presentation. While the review is happening, there will be pre-merge testing where you may do a quick build and report whether the patch gets applied correctly or not. These are all automated stuff. Once the reviews are done, the patches get merged and they land into the Git repositories. This is what happens with the lifecycle of a single patch. But after that, you still want to do testing on a nightly basis where you collect all these Git repositories where these patches have been merged, and then do a nightly build and then run a subset of CTS and VTS and custom test suite. CTS is compatibility test suite, and VTS is vendor test suites. These are special test suites available as part of Android to verify whether your Android is working as expected. Generally, on a nightly basis, you would run a subset of all this stuff, and weekly you would do a build on which you'll do a complete CTS, VTS test, and then run custom suites, and then you'll go into RC testing, where you'll run all these weekly tests. Basically, the number of tests that you're running keeps growing as it gets closer to the release. This is general workflow overall. Along while you're doing this, the problems that arise, the challenges that arise is you have your nightly tests, you have your weekly tests and release tests. All those things have to run on the limited test of hardware that are available in your lab. The picture that I've shared is just for just to showcase the complexity in a lab. This is app testing lab from Uber, posted on Twitter by someone. I've shared the link. It was posted by Smith. Just to showcase how complex the labs could be. This is just end device, but if you look at development boards, it will be much more complicated. So what happens when you have so many tests being run on these hardware? You'll run into shortage of this hardware. That will result in queuing up all of your test suites that are supposed to run. You'll have your results coming in late. Your nightly results may be coming after a day or so. These are kind of problems that you run into, and you'll have flaky hardware where sometimes device reboots but doesn't boot, or some other issues. And if you have a simulation test case where you have Wi-Fi environment where you connect two devices and try to talk to them in between those two devices, you may run into issues. Just to explain how complicated, how complex the testing environment would be and how costly this would be, the problem will become multifold when you're working with multiple Android code bases as well in your setup. Yeah, this is all the challenges that come associated with real hardware as well. This is the stuff. And Sumit has touched upon this topic in detail, that pixel device support were removed from AOSP with Android 16 releases, but the developers from Android team posted this clearly stating that they're pushing to use CuttleFish as the reference target on AOSP code base. This has been in development for 7 to 8 years in the past. The core Android team use it internally for their core daily development for common kernel as well as other stuff. And this is why we're here discussing how you can use CuttleFish, which will solve some of the problems with testing and all the stuff. What is CuttleFish? It is an Android virtual device. It's been used by kernel developers, systems developer, and BSP developer before a particular hardware is available. You can parallelize your stuff. You can develop your customized Android and test it on this virtual device at the same time before hardware is available or your form factor device is available. CuttleFish is Vertio compliant. It can run on x86, ARM64, and RISC v64. You can run it locally, as well as if you want, you can scale it in the cloud with GCE, AWS, or you have a large server in your premise itself. This is a block diagram. I've tried to capture it. You have a native hardware. You can take it as your laptop on which you're running your host operating system. Could be Linux, or you could have your own hypervisor. And CuttleFish will use something called as CrossVM. This was developed by Google for the Chromium project to run Android apps on top of it. It's a virtual machine monitor, VMM, on which you will then spawn the guest OS, which will be your Android image that is going to run. CuttleFish is Vertio compliant, meaning any hypervisor which is Vertio compliant, on that you can run the CuttleFish image or any derivative of CuttleFish. The Trout reference target in automotive Android is again a derivative of CuttleFish. It is also driven through Vertio interfaces itself. So this is how CuttleFish is trying to solve the problem, trying to free the platform developer and app developer needing the real hardware itself. CuttleFish is a high fidelity device, a high fidelity virtual device, trying to be compliant, as compliant as possible with the real hardware. All the HALs have been implemented. Most of the HALs have been implemented to the best of my knowledge. And if you're able to run an app on CuttleFish, you'll be able to run it on a real device. The images that you built are API compliant and stuff. And the goal is to enable scalability that you can spawn multiple instances of CuttleFish and run your tests in parallel. At the same time, you don't have to have 10 hardware connected to your laptop and stuff. If you're able to have one server where you can spawn 50 CuttleFish instances and run, that way overall in long term it will help you reduce overall costs as well. At the same time, CuttleFish is configurable, so that you can configurable to whatever form factor you want, a single display, dual display, and configure the RAM and CPU to test various configurations. I've put some instructions for people to try. The way CuttleFish is packaged is the cross VM and all the needed software stack is hosted on GitHub repository. You will build, it'll use Bazel and build a few Debian packages. You can then install it. It runs with the KVM interface. So you'll have all of them installed as a prerequisite. You can then build AOSP. Since I wanted to keep the slide small, I have posted a link for ci.android.com. That's where Google publishes pre-built images, which you can download the CuttleFish images and then run locally. I've just taken a screenshot of the CuttleFish instance that I run on my machine. The package itself will have certain wrappers called as launch CVD, which is a CuttleFish virtual device. The CLI will take care of launching the CuttleFish instance, and it provides you certain log path where you can check all the logs related to the CuttleFish instance that you've booted up. This is a screenshot of my local CuttleFish instance that I had run. I have configured it to have dual display. It has display 0, display 1, but it is running with same screen on both of them. So you can simulate these scenarios and develop app and stuff if you need. With the CuttleFish virtual device, Google has introduced a concept called CuttleFish hybrid device, where you can take your phone's system image that you've built for that device, take that and take the reference CuttleFish image, and you can merge them to create a CuttleFish hybrid device, which will boot on CuttleFish but will run the system image. By system image, I'm talking about the skinning and stuff which are there as part of the device. If you take a Pixel phone, the software stack that you're running with all the custom UI is quite different from what you built from AOSP. So you can take that image and then merge with CuttleFish and run them on a CuttleFish instance. This is how Google also uses this CuttleFish hybrid device for development and scalable testing of the changes that are just associated with framework related stuff on the phone. What I showed was about running CuttleFish on your local machine. Google has posted another project called CuttleFish Android Orchestration. This project is developed by Google. It's designed in such a way that you can deploy it in any cloud environment. They've verified it, and the instructions posted are for GCP. GCP is Google Cloud platform where you can spawn VM and run things. You can use that orchestrator. You can create multiple CuttleFish instances using your local machine, but all these instances will be running in the cloud, and you'll have connections over ADB on your machine, and you can still directly communicate with those multiple CuttleFish instances. It is called CuttleFish Android Orchestration. There was an alpha release last year for this project. It is in active development. You can take and deploy your own orchestrator and use it. This is a block diagram how the cloud Android orchestration works. There are two configurations for this tool. One is you can spawn a remote machine and run the cloud orchestrator there, and there is another configuration which I've not described, where it will use other serverless functions of Google Cloud with an API interface, and then it will spawn VM. But in this particular architecture, I'm just talking about one remote server. You can assume it being a large server with 128 or 200 core machine. Inside that machine, you will have a cloud orchestrator. All these are run as Docker containers. The cloud orchestrator itself is the one which you'll run on that remote machine. And the cloud orchestrator then will wait for API connections from remote machines. On my local machine, I'll have a tool called CVDR, CuttleFish Virtual Device Remote, CLI, and that will talk over REST API to the orchestrator. You can request, I want 10 CuttleFish instances, and it will spawn and manage all those instances remotely for you. And yeah, all the Docker containers will be running on that particular remote machine. The communication between the two will be REST API for spawning, and there's another technology called WebRTC, which will allow you to stream the Android screen that is running on that remote machine directly into your browser and allows you to interact with them. I have few screenshots. I'll show them next. Yeah, the way Google has packaged all this is in the form of container. You can directly run the cloud orchestrator in the Google Cloud VM. I've given the instruction. They've published this as a container. You can just pull it and run it. You have an interface with the config file where you can tweak things, what has to be enabled and disabled, like authentication and all this stuff. As I've mentioned, the container itself will bind mount the Docker socket from the remote machine inside to the orchestrator so that it can start spawning and managing all your new CuttleFish instances. Assuming that this stuff is running in your remote VM, this is the CVDR tool showcasing how things run. CVDR list will try to find all the running CuttleFish virtual devices on your remote machine and list them. As on the first run, it's not showing anything because I've not run or created any new instance. The second command is CVDR create, to which I'm passing the CuttleFish image that I've created, along with the host package, which contains all the related tooling for CVD. This is also gets built as part of AOSP. So the tool will then transfer these packages from your machine to the remote server, cache them, and then spawn the instance for you, and provides the links where you can see the logs as well as interact with the device in the cloud. Here I've spawned one CVD instance, and the next time I call CVDR list, it's showing that one instance is up and running. And it's also showed that ADB connection is available for that particular instance. I've taken screenshots. I would have loved to demonstrate, but I've taken screenshot. This is my CuttleFish instance running in GCP VM, and the corresponding logs are again accessible in the cloud for you to view them and debug them. But these APIs are good enough for you to automate and download the logs and view them locally if you're doing any kind of automation. The one on the right is the logcat output for that instance which I'm running. I have a couple of more screenshots. One which describes the launcher logs itself, whether the CuttleFish instance was getting launched correctly or if there are any errors if you want to see. The screenshot on the right side showcases the bootloader U-boot and the kernel logs running for that particular CuttleFish instance. This is some of the public information that I've found. The CuttleFish team itself uses an on-premise ARM server setup on which they run the CuttleFish hybrid device. They run 40 CuttleFish instances and use it for their development. And AWS has, I think, a couple of months back demonstrated that CuttleFish can be run on their ARM64 servers in a container setups using Kubernetes and stuff. I have left the links for the documentation, as well as there is an interesting, a very good presentation by Ram from Google in LPC, which talks about CuttleFish and how it can be run. And also I've given the link for the cloud Android orchestration, which can be used and tried out and played around if you want to try the scaled CuttleFish in the cloud. Yeah, thank you. Yeah, if there are any questions, I'm happy to take.
Hi, one quick question. Is the tooling within Android Studio currently able to hook into, like, let's say, for example, Logcat for CuttleFish that runs in the cloud?
It will work directly because I think that will talk to the CuttleFish instance. Basically, it is using ADB to find what is happening, right? Once you spawn a CuttleFish instance wherever, if you're launching it in the cloud or local machine, CVD will try to establish the connection with your ADB server running on your laptop with that machine automatically, that VM automatically. And your Android Studio will directly start talking to that over ADB.
Understood. Thanks, yeah.
Okay. Okay, thank you.